The fourth property is saying that to add I from 1 till n for that I. And I told you I is a counter from 1 till n. That's mean you can replace instead of I the 1 or 2 or 3, 4, 5 till you end it by n. The property telling you that you will get a fraction with n and multiply by a bracket n plus 1 over 2. Let's prove that by this example. A summation from 1 till 4 for I will be equals to, I told you, replace I by its value. Once by 1, then 2, then 3, till 4, because it ends here in our example till 4. And because we have here summation symbol, so we're going to add them all. We can't subtract here at all. So that will be, after you add it, it's 10. And if you're going to use that rule, you can see that n is 4, and you're going to add it, and you're going to add this 4 also by 1 to get 5. 5 by 4 is a 20. Divided by 2, it's 10. It's the same result if you can add it from here. That's mean you can use this rule if you have large numbers of n, like for example, 100 or million. You can't actually write the summation from 1 to million. That will be hard for you, but it is easy to use that rule for adding. Property number 5, summation of I from 1 till n of I square. The same as before, but we are going to square each I to get that rule, which is n times n plus 1 in a bracket multiplied by 2n plus 1 in a bracket, all divided by 6. To understand this, let's have the following example. The summation from I equals 1 till 3 of I square. You are going to replace I by 1 to make it 1 square plus 2 square plus 3 square. And that, according to the equation, you will give you the following rule. 3 as n multiplied by 3 plus 1 times 2 times the 3 plus the 1 all in a bracket. Calculate all and divide it by 6 and you will get the following. A 3 from up multiplied by 4 from inside the bracket and multiplied by 7 which is inside the other bracket. This all divided by 6 and the whole answer will give you 14, which is similar when you're going to square each then add them. So it is easy to use that rule instead of using that long way if you have large values of n, like 100 or million. The next property is I equals 1 till n of I cube, which can be equals to n squared times n plus 1 squared over 4. Actually, this rule is similar to that one exactly, but each term is squared. Watch it and try to compare to make it easy for you to remember. An example to understand it more, the summation from 1 to 5 of I cube will be equals to, replace instead of an I by 1 to make it 1 cube, then plus 2 cube plus 3 cube plus 4 cube till you end it by 5 cube because the last value of n is 5, which is all equals to 5 squared times inside the bracket 5 plus 1, add it, then square it, and then divide it by 4 to get the following result. 25 multiplied by 6 squared over 4, which equals to 25 times 36 over 4. After you cancel 36 by 4, you will get 9. 25 times 9 is 225. This is a nice way to add these large numbers when you have a large value of n. So these are called the properties of Riemann's sum. And an example for each. Example number 1. Find the area bounded by the graph of f of x equals x plus 1 and the x-axis on the interval from 0 to 4. To find the area bounded by the graph, you are going to use the definition of the finite integral, which we explained it before. Solution. You have to divide the interval from 0 to 4 into n equal parts. The length of each is delta x equals b minus a over n, where delta x will be equals to 4 minus 0 over n, which is 4 over n. And you can see that b, we are going to take it from here, which is clear in the interval. And a is going to be taken from also the interval from 0. Because of that, you can say that a is 0 and b is 4, which can be written as 4 minus 0 over n. N always is unknown value because it is the number of rectangles and it is always unknown. Then the next step is you need to find the length of each rectangle by using f of xi star by replacing the rule of a plus b minus a over ni instead of each x in the function. And remember, a is 0, and this b minus a over n we calculated in the previous step, which is 4 over n, to be 0 plus 4 over ni. And after add it to 0, you will get 4 over ni alone. And replace it instead of the function in the original function, in the equation itself, which be here. Replace it instead of x and add it to 1 to be written as 4i over n plus 1. So this is the length of the rectangle and this is the width of the rectangle. Length and this is the width. The next step, we need to multiply them to each other and add the whole rectangles to get the sum of the areas of rectangles by writing summation of I from 1 to n for the length for I over n plus 1 multiplied by the width 4 over n. Length by the width. Multiply, then add them all to get the sum of all the rectangles. Then, by using the properties that we discussed before, you gonna let the sum to get in for each because you have a plus in the middle. But before, you have to multiply this 4 over n by 4 over n to get 16 over n square I plus, and after you gonna multiply 4 over n by 1, you will get 4 over n. This summation will get n for the first term and to the second term. Then use the property, which is property number 2, telling you that you can take the constant outside the summation as a common factor and leave the variable, which is I, because I is only the variable, not n. N is the number of rectangles, which is constant. And I is a variable now, which gonna stay inside the summation. Plus the summation of I from 1 to n for 4 over n. Now we're gonna use the properties again by leaving the constant outside and think about property number 4. Summation from 1 till n of I will be used as that rule, n times n plus 1 over 2. Then plus, then take plus and write it as it is here. That will let you use the next property, which is 4 over n multiplied by n. It is actually property number 1 because 4 over n has no I, and anything has no I, it is constant. That means the constant all multiplied by n by using property number 1. Then try to simplify your work after using properties by canceling, for example, this 2 by this 16 to get 8, and this n by this n square to get n down. Then open a bracket and simplify your work. And similar here, you can cancel this n with that n. You can get 8n plus 8 over n plus 4. Then the way to find the area from 0 to 4 by using the whole rule, by using the limit when n approaches to infinity, that means you're going to make the number of rectangles infinity rectangles to make your work accurate and to get an accurate value for this integration. For the f of x, I multiply by delta x, and that will give you the limit for the last results that you get, which is 8n plus 8 over n plus 4. Now you are going to equal denominator and try to take the highest power up with the highest power down like we learned before in limits. That means from the first bracket, you can take 8 over 1, which is 8. And from the second term, you have 4 alone, just take it. And add 8 plus 4 to get a 12. And the unit for this area supposed to be squared. It is an area. So this is how to calculate the area bounded by a graph and the x-axis by using the definition of the integrals of the finite integral.